everyone. As Jeff said, I'm Ed. Welcome to Dev Ignition. And this is a talk about Kubernetes. Quick show of hands, how many people have used Kubernetes before? 2? Okay, good. This talk may not be for you because this is a very introductory talk, but it's good that the majority of you have not used it before. If you're not lying to me, I hope you're not. So, all right, really quick, if you were here this morning, you've already seen this slide before with a picture of my colleague Snehal instead of me on there, but I work for Solution Street. We're run by software engineers. We have mostly commercial clients. We have a lot of great engineers, and we use just about all tech stacks. So our headquarters in Herndon, and we are hiring. There's a whole table of us sitting right there, so if anyone is looking for work, come talk to us. Come talk to us about anything. We're happy to talk. Okay, so let's get started. What is Kubernetes? Well, in one sentence, it's a container orchestration framework. You can think of its job as you give it a state, and its whole purpose in life is to converge to that state. So that's what it does. You tell it what you want, and it makes it so. It's very well suited for applications that scale horizontally, or stateless applications. It can also accommodate portions of your infrastructure that are stateful. Don't let anyone tell you otherwise. It's a common misconception that Kubernetes can't handle that. It was built to scale horizontally, but it can accommodate your stateful needs. And we'll talk a little bit about that in a bit. So how do you use it? Well, a show of hands of people who've packaged things with Docker before. All right, that's good. Good. We've all heard of Docker. So Kubernetes, you have to use Docker to package your container, to package your application, or Podman, or some other container framework. I know I use Docker. I know Kubernetes supports Podman. I think they may even be encouraging people to move in that direction. And then you run those Kubernetes containers on, you run those containers on Kubernetes pods, and then you let Kubernetes manage the pods for you. Okay, so why go through the hassle? And I'm not gonna lie, it can be a hassle. It's a lot of work to get Kubernetes up and running. There are no easy options. There are slightly easier options. So why would you want to do it? Because it's a significant investment in infrastructure. Well, it can manage resources for you. So it does what you say. You ask it for 100 pods, it gives you 100 pods. And then, more importantly, it ensures that those 100 pods are always running. Horizontal auto-scaling. So you're experiencing too much traffic, you can tell Kubernetes how to measure that traffic and how to scale. So if you're getting a lot of traffic, Kubernetes will scale up for you. It'll create more pods. Not getting a lot of traffic, you can configure it to scale pods down. Once up and running, that's a huge caveat. Again, that's where all the expense is. But once you have Kubernetes up and running, it can ease some of your operational burdens. For example, you can assign resource quotas at the namespace level. And then you don't have to have people coming asking you for resources. You just give them a quota, and this is how much of the cluster you can use. You can grant access to individuals or groups at the namespace level. You can manage ingress in a central place. And then, honestly, I don't know. Find an ops person in this room and ask them more questions. I'm a developer, so that they will give you much more details. I'm honestly winging it for those 4 bullets there. But as a developer, what I know is that the ops team has the opportunity to put all of their guardrails in place in one place and configure it, and then I'm just free to go create services, and as long as I don't bump up against the quotas that they've assigned to me, I can create services. I don't need to ask someone to roll it out. It's very easy, very convenient. Okay, so like I said, Kubernetes horizontal scaling, right? So if you have an app that benefits from horizontal scaling and you are bumping up against scaling constraints, Kubernetes is a good option for you. But then it raises the question, how do I know if my app is easily horizontally scaled? And we're gonna build down in complexity, so this is the easiest answer. If your app only consists of stateless components, boom, you're all set for Kubernetes. You can horizontally scale. An example I thought of here is if you created an application that converts Word documents to PDF documents. It's one request. You send it a Word document, you get a PDF document back. If you have one user, you need one pod. But with Kubernetes, if you have 10,000 users, you can have 10,000 pods. And with no extra work beyond the initial configuration, you can service 10,000 users in the same amount of time it took you to service one user. Okay, so slightly more complex. Your app has stateless components, but the stateful components, stateless and stateful components, and the stateful components are not the bottleneck. So I was told by one of my managers at work that I needed to put this footnote here. I forget my age sometimes. If you're younger than 35, you may not know what SETI at home is. I don't know, a show of hands of people that know what SETI at home is. Okay, that's about half. There was an organization, I don't know if they were affiliated, it wasn't NASA, I don't know if they were affiliated, it was a nonprofit, and they would essentially record noise from space and then try to determine if there was a signal in it. And they had a whole bunch of satellites pointed at space. And they were compute constrained, but not database constrained. So the way they solved that problem is they created a free screensaver, and then you could download it, and they were not hiding this from you. They told you that while the screensaver was running, they were analyzing signals that were sent to your computer. So they found a way to scale their application horizontally by fixing their compute constraint, and then presumably all of those applications were sending data back, just a Boolean, yes, it's a signal, no, it's not, to their centrally managed database. So again, they had a huge pile of state, but it wasn't the constraint that was preventing them from scaling. So, okay, so slightly more complex. You can find a way to scale stateful, so you do have a stateful component, and it is a scaling bottleneck, but you can find a way to scale it that will let you scale it horizontally. The example I use here is if you have an application, a read-heavy database that is light on updates, you can create read-only replicas. So I worked at the American Registry for Internet Numbers many years ago, and they implement Whois, and the way that they implemented that was they had their database that they managed, which was the product they provide, and then they created read replicas of that data that they replicated data to once or twice a day, and that would service all Whois queries. So they could scale that horizontally. And finally, if you can't scale it, this is a more complicated way. I don't want to get into too much detail. The moral of the story is the further you go down this graph, the more unique the solution is going to be to you. But if you can find a way to scale your stateful components horizontally, then the stateless part, Kubernetes will easily handle for you. Okay, so we're going to talk about what deployments look like on Kubernetes. So you start out with an application. I'm a Java developer, so for me this is a jar file, but Ruby, Python, whatever your language is, whatever it is that you produce that is what you call your application, that's what that block contains. So again, for me, this is a jar file. Then you have to have a step where you, like we talked about, you put that in a Docker container or a Podman container. Then you push that container to an image repository. And then we'll talk about this in a second, but yeah, magically you have a Kubernetes cluster, right? Well, that Kubernetes cluster is configured to pull images from the same image repository that you push your Docker containers to. And then you start some pods on that cluster, and when those pods come up, they part of the pod manifest describes which image it uses, and it just pulls from the image repository. So, and we'll see this in action, but yeah, once those pods start up and pull your image, your application is running. Pretty simple, right? All right, so let's go a little bit deeper. First, though, I want to talk about some tools. And this is a little bit of a review of things I've already talked about. It's very important that you're familiar with. I use Docker. Again, Podman also works. Come talk to me afterwards if you know about Podman and can sell me on it, because I have reasons for wanting to move away from Docker. But yeah, I'd be interested in having that conversation. But that's how we package our applications, and it lets us put them in a place where Kubernetes can find them. Minikube. So I'm going to be doing a live demo if all goes well. I'm using Minikube, which is a Kubernetes cluster that you can install on your laptop. Highly recommend checking it out. Again, just a note here, it's for development purposes only. You wouldn't want to serve production traffic with it. But it's super easy. If you have a Mac, just brew install Minikube, wait a little while, and you'll have Minikube up and running. It manages virtualization for you under the covers, and it starts a Kubernetes cluster. In newer projects, so this presentation is pretty old. I put it together a while ago. I used Minikube. For new projects, when I want a local environment, I use K3S or even K3D, which is K3S inside of Docker containers. Both worth checking out. And they leave an even smaller footprint on your machine. With K3D, you can just do Docker delete, and it's as if it never existed. It's super convenient. Helm. So Helm is the primary tool. Helm is the primary way that Kubernetes applications are packaged. So Helm is a tool that takes a application package and rolls it out to a cluster, is the way to think about it. And Helm is extremely simple. It's crazy how simple it is. Literally, it's just a set of templates that are a tar gzip archive. And then Helm knows how to manage that. And that's a little bit of a white lie because it does add one more feature is Helm supports Go templating. So when you're writing these templates, and we'll take a look at some Kubernetes templates, big chunks of them can be very repetitive. Go templating lets you manage some of that repetition. So Helm essentially applies Go template transformations and then just makes a bunch of API calls to the Kubernetes server and it tells it what you assert that the state should be of the server. And finally, kube control. This is the Swiss Army knife of Kubernetes. It's how we create, read, update, and delete Kubernetes resources with the caveat of we use kube control when Helm would be overkill. So kube control, you can do anything to a Kubernetes server. It is a very thin wrapper around the Kubernetes API, and we'll take a look about that. So Kubernetes, everything that happens on Kubernetes is done via the Kubernetes API, and kube control is essentially, you can think of it almost as a wrapper around curl. Under the covers, all it's doing is just making API calls to the Kubernetes server. Okay, so now we're going to talk about the cluster. So the base of the cluster is Kubernetes nodes. These are the possibly and even likely virtual machines that make up a Kubernetes cluster. They don't have to be virtual. Plenty of people run Kubernetes clusters in rack-mounted servers, although in my experience, that is becoming more rare. I'm just one data point. I don't know if that's a trend, but a lot of people will just use managed Kubernetes services. AWS has one, Google has one, and Azure has one. We'll talk about those in a little bit. And then Kubernetes' whole job is to schedule pods on these nodes. And like I just said, managed services. So one of the benefits, among others, you get with managed services, so if you're going to run your own Kubernetes cluster, you can stand up racks in your server room and put hardware in there. Like, it's really expensive, and then you've already paid for that hardware, right? So you're not really benefiting from the scaling down of Kubernetes because it's already running on hardware that you paid for. If you use a cloud provider, especially one of their managed services, and again, I'll make these slides available after this, but these are links down at the bottom of the slide. EKS is Elastic Kubernetes Service, which is AWS. AKS is Azure Kubernetes Service, which is Azure. GKE is Google Kubernetes Engine, which is Google's provider. The benefit of using these is you pay for what you use, and they offer a level of abstraction. So Kubernetes can scale pods up and down. If you use a managed Kubernetes service, it can scale nodes up and down for you, which is when you can really get into, I hesitate to say cost savings because the cloud providers are expensive, but you can certainly correlate your usage with your costs more effectively. In other words, if your cluster is being underutilized, it will use fewer, in AWS, for example, EC2 instances are what your nodes would be running on. Okay, so now I'm going to start building up a picture. This is our Kubernetes cluster at the moment. We're going to talk about a 2-node Kubernetes cluster. And now we're going to talk about the things that we're going to put on this cluster, right? So for my demo, there are plenty of Kubernetes objects, and I will call them manifests. A manifest is the textual representation of a Kubernetes object. And like I said, we will look at some of those in the live demo. I will be dealing with 4 types of manifests. So on the right-hand side, upper right corner is the most important one, the pod. This is the building block of Kubernetes applications. Pods are managed by ReplicaSets, and ReplicaSets are managed by deployments. And then services route traffic to pods. So we're going to a little bit more detail, but take a mental snapshot of this picture. Deployments manage ReplicaSets, manage pods, and services don't manage, but they route traffic to pods. So we're going into more detail now. Pods, and not containers, that's very important, are the fundamental building blocks of a Kubernetes application. A pod is a group of one or more containers that work closely together on a specific task. Pods, again, the pod manifest is just a YAML file where you can specify some configuration. One of the things you can configure in there is you can create volumes for your containers. So you can create the containers themselves. Of course, a container can write to its local file system, but in Kubernetes, anytime a container writes a file or reads from the file system, you probably have some external storage set up, and volumes are how you specify that external storage. And then once it's a nice abstraction that Kubernetes creates is you can create a volume object and you can mount it into any pod that you want. So you can do cool things like have two containers in the same pod that mount the same volume, and they can now do inter-process communication through the file system. Another important thing in the pod manifest is health checks. So you, via the pod manifest, tell Kubernetes how it can ask your pod if it's healthy. And so Kubernetes constantly, every, I think maybe 5 seconds by default, asks your pod if it's healthy. If your pod doesn't respond, Kubernetes kills it and restarts a new one. So again, when we talked about earlier, this is how Kubernetes can guarantee if you ask for 100 pods, that you have 100 pods and that all 100 are healthy. And if they're not healthy, you can have confidence that Kubernetes is working very hard to try to get you 100 pods that are all healthy. Okay. So pods are managed by ReplicaSets. We're going to talk about pods a little bit and why ReplicaSets are important. So it's important to remember that pods are ephemeral. They're replaced if unresponsive, which we talked about. They can be deleted on one node and added to another. That's how pods are moved. And for scale down events, like we talked about in Kubernetes managed services where they can scale down nodes, when EKS, for example, deletes a node on your cluster, that node probably had some pods on it. It has to put them somewhere, and so what it does is it moves them to the other node. And the way it does that is deletes it and then recreates it. And this is the most important part of the presentation, maybe, if you want to understand how Kubernetes works. You cannot prevent either of these things from happening. And there are ways that people try to prevent it, and there are ways that you can prevent it, but it behooves you to work under the assumption that Kubernetes is going to delete and recreate your pods. If you write your application and don't assume that, I guarantee it will give you headaches in the future. So with ReplicaSets, volumes, so when we move a pod, volumes don't follow pods and host names don't follow pods. That is the primary difference between a replica set, and this is the only slide that I'll mention this on because I had to cut this out from the demo because I didn't have time, but the alternative to a replica set is a stateful set. And the difference between a stateful set and a replica set, the key difference is that it guarantees these two things. So a stateful set guarantees that if a pod moves from one node to another, or if a pod is for any reason deleted and recreated, the new pod that is recreated will have the same exact volumes mounted to it. So the same file system will be mounted, and it will have the same host name it had the last time that it was instantiated. There's a very deep philosophical question about identity in there and how it's defined. But yes, that is exactly what a stateful set does that a replica set does not. And that is how you deploy stateful applications on Kubernetes. Again, I won't have time to demo that. Well, we'll see. I do have a stateful app running locally, so we might be able to take a look at that. Okay, so what are deployments? Well, again, remember, pods were managed by replica sets. Replica sets were managed by deployments. So what features could I add on top of a replica set? Again, I don't think I mentioned on the last slide, a replica set, another thing it does is you can tell it how many instances of your pod you want, right? So the question becomes, what do deployments offer that replica sets do not? Well, the one example I could think of is they offer rollout strategies. So the deployment will allow you to specify, when I deploy a new version of this app, I want to do a canary first. And if that canary receives traffic without errors, then I want to remove the canary and create I want to replace pods of the old version with the new version. Rolling update gives you more fine-grained control over that. You can say, I want to, when I roll out my application, I want to roll out 25% pods of the new version, 75% of the old one, and then you can specify how I want to transition. I want step 2 to be 50, step 3 to be 75, and step 4 to be 100%, and you can set constraints at every step and say, assuming that there are no errors, for example. So those are the features that deployments give you. Why did I use deployments in my demo? Because when you ask Helm to create a new application for you, it creates a deployment by default. And it was nice to talk about, right? Really, if I'm trying to make the most simple demo possible, I wouldn't have included a deployment. I would have just included a replica set. And finally, services. So services are ways, you could think of them as ways that you give names to your pods that people can address, right? So this type of service I'm going to use in the demo is going to be a load balancer. And a load balancer is a service that has an internal cluster IP address and an external IP address. And a service's whole job is to listen for requests on either of those IP addresses and then forward those requests to the pods that they, I'm being careful with words here. They don't manage pods, they just route traffic to pods. So a replica set in a very real sense is responsible for pods and it has the power to delete and recreate them. A service only needs to know that they exist and then will distribute traffic to them. It has no responsibility for creating or deleting pods. It just needs to know you're healthy. Okay, well, I have a request here and you're next in the queue, so I'm going to send it to you. Okay, sample application. I'm going to describe this really quickly. I wrote a sample application that does nothing other than suggest a random subreddit. It's stateless. I have a list of 280 subreddits. On the last slide, I'll show you where I got that list. A little bit of a warning, I did my best to clean that up. Selecting a random subreddit is risky business, so I will apologize in advance for anything that shows up on this screen. But again, I made a pretty good effort to clean that list up. So the list never changes. It doesn't need to, the application doesn't need to store anything anywhere. The list is just in memory. Any pod has the same list. Start it up, start servicing requests. So this is what the application looks like. These are all the things we talked about. We have 2 nodes, 3 pods. Node 1, node 2, pods 1, 2, and 3. We have a load balancer responsible for distributing traffic. And then we have a deployment through a replica set that's not pictured here is responsible for ensuring that there are always 3 pods. All right, so let's see it in action. Before I do that, I want to tell you what I've already done before I show you the demo, right? So the state that my machine is in right now was achieved after I started Minikube. I configured Docker to talk to Minikube's Docker host so that when I push images, they go to the right place. I built the application. It's written in Kotlin. I use Gradle to build it. I packaged it as a container, and then I pushed that image to the repository. I already ran Helm, so all of our Kubernetes components are on the cluster. I proxied local ports that will talk to the load balancer. So I don't have an external IP address on the load balancer. I'm just forwarding local ports to its internal cluster address, and it will distribute requests. And one more thing, in Minikube, I don't have a 2-node cluster. I have a 1-node cluster. So this is an exact image of the app that I'll be demoing. So first of all, we'll just bring the app up. So here, food haikus. All right, so that's probably a safe one to click on. I'm not going to do it. But if I refresh this, I want you to watch right here, the name. So watch these last 5 characters, and we'll see that they're changing, not as often as I want. But there it changed, QN, QDX, JB99R is a popular one, QN. There we go. So now we've seen all 3. So that's just proof that when I'm making these requests, that the load balancer is distributing it to multiple pods. Wrote myself a little script here to make sure I don't forget anything. So now let's look at the cluster. Actually, let me show you this first. So this is a tool called K9S, which is a graphical representation. I also have another graphical representation, which is the Kubernetes dashboard. To me, I think this is too noisy for a demo. There's a lot going on here. Very briefly, I'll show you that we can see that we have one deployment, we have 4 pods, and that's because I have 2 apps deployed here. 3 of those pods are for the stateless app, 1 is for the stateful app. I have 1 replica set and I have 1 stateful set. I think this is too noisy, so I'm going to use this UI. But another thing that I want to show you is kube control. So I talked about kube control a lot. If you want just straight command line, we can ask kube control to show us all the pods. There they are. So there's 1 stateful app pod and 3 stateless app pods. But what I really want to show you with kube control, so if you noticed here, when I ran that command, I had this bit commented out. In kube control, when you're running it, you can set the verbosity level. If you set the verbosity level to 8, again, just proof what a thin wrapper it is around the Kubernetes API. It will tell you exactly the calls that it's making to the Kubernetes API. If you want to learn the Kubernetes API, if you have questions about how it works, kube control -v equals 8, and just start running commands. And this is even quicker than reading the documentation. Super easy way to learn it. All right, there we go. Okay, so let's take a look at our application on the cluster. So we're starting at the deployment, right? So here we have a deployment. We can open this thing up, and this is what a manifest looks like. It's just a YAML file. The deployment is interesting. Let me come back to that in a second. So if we go into the deployment, we see that we have the pods. We can also look at the replica sets. So here's the replica set with the deployment. I just wanted to show you that all of those things exist on the server. I wasn't pulling your leg there. So now if I go back to the deployment, in that manifest, since I'm using a deployment, when I create this YAML file and package it up into a Helm chart so that I can roll it out, I'm responsible for specifying the replica set and the pods in the deployment. So here we look at this and we see it is in fact a deployment. The YAML file has this is all standardized by the API, what these fields need to be. You need to tell Kubernetes what kind of thing it is, deployment. This API version, if you look at their documentation, this tells you that the deployment object is in the apps v1 namespace of they have multiple namespaces. And then if we go down here, we'll see that this spec, and this is, you just know this from looking at these things long enough, that this spec is actually what a standalone replica set manifest would look like. It's just embedded into the deployment manifest. We don't have to specify the kind because that's the only kind of spec that fits here. And then embedded in the replica set spec is a pod spec, which again is another type of manifest. The only thing of interest, well, a couple things of interest here. Number one, we can see that the image, so there's no magic here. I'm just telling it what image to use. Kubernetes itself is already configured to pull from a Docker repository, so that's controlled somewhere else. Here we have the liveness probe, so we're just telling, hey, Kubernetes, if you want to check if this thing is live, hit this path, use this protocol, HTTP, and if you get a 200, you're good to go. It's alive. If you get anything other than a 200 for more than, say, 15 seconds, kill the pod and start it over. Oh, and here we tell it how long we pull. So we're pulling it every 10 seconds. We tell Kubernetes, don't nag us too much, ask that question every 10 seconds. So now what I want to show you is right here. Now, before we had 4 pods, since I navigated to this through the deployment, you'll notice that it has constricted this to only the stateless app. But I want to show you that I have 3 pods here before I go back to the deployment. And you can edit these manifests in line. And I'm going to up this to 6 replicas. Now, in kube control, what you would do is you would pull this YAML, change it, and then push it. K9s is doing that for you all behind the scenes. So it looks like I'm just editing it in line and saving the file. But now if I go to pods, we see that we're in this is Kubernetes in the process of converging, right? So we've asked it for 6 pods. It says I'm doing my best. I've got 3 running. I'm trying to get you 3 more. We can look into one of these. It's just a Spring application. Started, and pretty soon here it will tell us it was successful. I think that was Kubernetes. Actually, I don't know if that was Kubernetes hitting the endpoint or not. I don't know if I'm logging those. Still waiting. There we go. All right, so now all the pods are up. Now if we go back to the deployment, we'll see that the deployment is blue again. It's successful, and in this here, it tells you the ready says 6 out of 6, which means of the 6 pods you requested, 6 of them are ready, so I'm no longer red. I'm no longer complaining. I think if there's anything else I wanted to show here, we have a little bit of time, so let me check the slides. Don't ask questions yet. All right. So the other thing I want to show you is this is the application. I hoped I had zoomed it out to fit on one screen. There we go. So this is written in Kotlin. I'm a Java developer, but I'm a huge fan of Kotlin, so I think everyone should be using it. But if you combine Spring and Kotlin, you get this application that fits almost on one page. You see right here, I have 2 endpoints. They both call the same function. So this is the function. All it's doing is getting a random subreddit. Every time, it's very inefficient. It loads the entire JSON file, which is 280 subreddits, into memory. It doesn't keep it there. It loads it in every time you ask, and then it shuffles it, and then it returns the first one. So it's a random one. 2 endpoints. This one is the one you saw, which displays it using this very simple template. So this application is 2 files. The other one is an API endpoint that just returns JSON. So for any of these that we go up here, we can just say /API, and then we get this. And we can refresh, and we see, oh, dogs wearing hats. All right, that's a good one to end on.